17 Iranian ballistic missile launchers were active inside the Makran mountain range. Their crews had 48 hours to disperse, hide, and survive the opening American strike wave. None of them made it to hour 6. This is not a story about American firepower. Every country with a defense budget understands American firepower. This is a story about what happens when the most expensive warship ever built by human hands, a $130 billion nuclear-powered aircraft carrier, goes to war against an enemy that has spent 40 years studying exactly how to kill it, and why, despite everything Iran had prepared, the Strait of Hormuz opened anyway. The USS Gerald R. entered the Arabian Sea operating envelope at 700 nautical miles from the Iranian coastline. That number is not random. It is the precise distance at which the DF-26 intermediate-range ballistic missile, China's design, Iran's inventory, built specifically to kill American carriers, begins to lose terminal guidance reliability against a maneuvering target. At 540 nautical miles, the DF-26 is a serious threat. At 700, the Ford's evasion geometry degrades the missile's kill probability to a number the Pentagon considers acceptable. The carrier's position was chosen by mathematicians, not admirals. That same 700 nautical mile standoff created a different problem. The Zagros mountain air defense targets, the radar installations, the missile batteries, the command bunkers that had to be destroyed before any strike package could operate freely over Iranian airspace, were 1,100 nautical miles from the Ford's flight deck. An F-35C Lightning II carries 13,300 pounds of internal fuel. That is not enough to reach the Zagros targets, conduct an engagement, and return. Not even close. Every single strike mission required a tanker rendezvous. Hold that number, 1,100 nautical miles, because everything that happened in the Strait of Hormuz in the first 72 hours flows from that distance. At 2:13 a.m., the opening move belonged to a platform that has never been officially named in a Pentagon press briefing. Iran's Integrated Air Defense Network, the system linking the S-300 PMU-2 batteries, the Bavar 373 installations, the Tor M1 point defense units, and 17 mobile transporter erector launchers carrying ballistic missiles, runs on processing chips. Networked radar requires computers. Fire control requires computers. The coordination between a coastal radar station and a mobile launcher 40 kilometers inland requires a data link, and that data link requires hardware to process it. At 2:13 a.m., a high-powered microwave pulse from a U.S. stealth aircraft hit Iran's primary air defense network nodes. High-powered microwave weapons are not classified technology. The Air Force has acknowledged the Counter-Electronics High-Power Missile Advanced Project, CHAMP, since 2012. What CHAMP does is deliver a directed burst of electromagnetic energy that induces current surges in unshielded electronics. Transistors fail, circuit boards fail. The processing infrastructure that coordinates a networked air defense system fails, not slowly, immediately, simultaneously across multiple nodes. 17 command centers went dark in under 60 seconds. No explosion, no crater, no missile launch to track on radar.
The screens simply stopped working. Iranian commanders in hardened bunkers stared at blank displays and had no framework for what had just happened. Their backup systems came online. The backup systems also went dark. The pulse had not targeted a single radar dish. It had targeted the computers behind every radar dish in the network simultaneously. The most dangerous phase of the operation had just become significantly less dangerous. 20 minutes later, 2 F/A-18E Super Hornets launched from the Ford's flight deck. They crossed the air defense perimeter not as a strike package, but as a diagnostic tool. The Americans needed to know what was still functioning after the microwave pulse, and the fastest way to find out was to present a target and watch what shot at it. Two surface-to-air missiles launched from Iranian coastal positions within 90 seconds. The Super Hornet pilots noted the launch coordinates, executed 9G brake turns that compressed their bodies to the edge of consciousness, deployed magnesium flares, and cleared the area. The missiles chased the flares. The pilots reported the launch coordinates back to the Ford's Combat Information Center. Iran had just revealed two functioning SAM batteries that survived the opening pulse. Those coordinates went into the targeting queue. At 60,000 feet, above the ceiling of everything in Iran's surface-to-air inventory, the Northrop Grumman RQ-180 stealth reconnaissance drone had been on station since before the Ford crossed the Arabian Sea. Its synthetic aperture radar does not photograph, it maps mass and geometry, through cloud, through camouflage, through the thermal blankets Iranian TEL crews had draped over their vehicles before moving them onto civilian highway networks. A ballistic missile launcher has a specific steel mass and axle configuration. A commercial truck does not. The RQ-180's AI processing distinguished between them at 60,000 feet in complete darkness. All 17 TEL vehicles located. Coordinates encrypted and transmitted to the Ford via satellite. Loaded into the targeting system before a single Iranian commander realized the drone was overhead. Iran's counter was the Bavar 373 in passive mode, no radar emissions, listening only for reflected signals bouncing off the stealth aircraft's fuselage. Simultaneously, the TEL crews began shoot and scoot, moving every 20 minutes to break thermal lock. At 2:50 a.m., Iran's Cobra electronic warfare unit flooded the electromagnetic spectrum with broadband noise aimed at choking Link 16, the tactical data network connecting every American platform in the theater. On the Ford screens, 70% of the target icons disappeared. Here is the moment where most militaries pause and reassess. The sensor picture is degraded. The enemy has gone quiet. The strike window is closing. What the U.S. actually did was send in assets that did not need the picture to survive. Two F-35Cs descended to 15 meters above the wave surface under full emission control, every active sensor off, running entirely on the passive data stream from the RQ-180 above. Alongside them, Kratos XQ-58A combat drones carried the weapons load. The F-35s stayed clean. The Valkyries carried the punch. Iran's passive radar was still listening. The Americans needed it to commit. The Valkyries released ADM-160 mauled decoys, miniature aircraft that use onboard electronics to simulate the radar signature of a B-52 strategic bomber. A swarm of mouths presents on passive radar as a carpet bombing formation bearing down on your most protected targets. In the bunker at Cape Casque, the Iranian commander watched what appeared to be a B-52 strike package and made the only decision the situation seemed to allow. He ordered the Bavar 373 to go active. The moment it transmitted, it stopped being a passive listener and became a geo-referenced beacon. The RQ-180 triangulated the coordinates in seconds. An AIM-174B extended-range missile from a Valkyrie's weapons bay closed the distance at Mach 3.5. The Bavar 373 radar cluster was destroyed before its operators understood they had been deceived. The shield was gone. What came next was attrition. More than 30 passive infrared-guided surface-to-air missiles launched simultaneously from the Makran mountain tunnels. No radar emissions, pure heat-seeking, filling the sky with propellant plumes from every direction. The EA-18G Growler arrived over the engagement zone and turned the electromagnetic environment into a dead zone. Iranian ground controllers trying to coordinate their SAM batteries heard nothing.
The F-35 pilots used the AN/AAQ-37 distributed aperture system, 6 infrared cameras embedded flush in the aircraft's skin, giving 360-degree spherical vision through the fuselage in every direction, to track every incoming missile while deploying MTV flares that burned hotter than jet exhaust. The infrared seekers chased the flares. The aircraft cleared the engagement zone. At 3:40 a.m., the RQ-180 reacquired all 17 TEL vehicles. They had stopped moving, parked in rock crevices with engines off. SAR does not hunt heat, it hunts mass. They were locked. AGM-154 joint standoff weapons, unpowered glide bombs with a 40-mile standoff range, separated from the Valkyrie formation and flew terrain-following profiles through the mountain valleys, below the ridgeline, below the line of sight of every short-range anti-aircraft gun positioned on the high ground above. All 17 launchers were destroyed. The secondary explosions from the missile warheads cooking off registered on seismic sensors in the UAE. Iran's final action was a swarm of Shahed-136 loitering munitions from coastal launch positions aimed at the ford. The Valkyries, running on autonomous AI targeting, intercepted the entire swarm outside the carrier's defensive perimeter, using onboard kinetic interceptors and solid-state laser modules. Not a single drone reached weapons range of the ship. At 5 a.m., the Strait of Hormuz was open. Now here is the part of this operation that will not appear in any press briefing. By day 5 of sustained operations at 270 sorties per day, something happens inside the ford that no missile can cause and no radar can detect. The F-35C pilots, flying 6-hour strike missions to the Zagros and back, are returning to a ship where the EMALS electromagnetic launch system cycles every 45 seconds, generating a vibration below the threshold of conscious hearing, but precisely within the frequency range that collapses slow-wave sleep architecture. The 8 hours of prescribed rest produces 4.5 hours of functional sleep. After 72 hours of that deficit, neurological impairment reaches the equivalent of a 0.08% blood alcohol level. The FAA grounds commercial pilots at that number. The Navy has no breathalyzer for sleep debt. A pilot returning from a 6-hour mission over the Zagros is now approaching a flight deck pitching 15 feet in Arabian Sea swells at 150 knots at night with a 0.5-second window to catch the arresting wire. A 0.5-second timing error is the difference between a safe recovery and a $110 million aircraft going off the bow. By day 12 of sustained operations, the mathematics forecast one major landing incident. The Ford's vacuum sanitation system, designed for steady-state crew loads, runs past its envelope under General Quarters surge tempo. Partial blockages produce pressure reversals. Pressure reversals in a sealed ship produce hydrogen sulfide in the berthing compartments. At 10 parts per million, hydrogen sulfide produces measurable cognitive impairment within 2 to 4 hours. The pilots calculating attack profiles are doing it in an atmosphere a civilian safety inspector would evacuate. The enemy did not deploy a chemical weapon. The ship manufactured one internally. On day 261 of the Ford's previous deployment, a fire broke out in a laundry space. Not combat damage, maintenance debt paying its interest. A crew that cannot launder its gear accumulates bacterial colonization on skin and mucous membranes. Colonization activates the immune system. The immune system burns calories. The crew is already running on a 30% caloric deficit, 4,000 calories required under thermal stress at surge tempo, 2,800 delivered. And the calories the immune system consumes are not available for cognitive function. Cognitive function determines whether the aircraft on the next recovery makes the deck or the water. The A-1B nuclear reactors aboard the Ford will output power for 25 years without stopping. That problem is solved. The biological problem is not. The Pentagon removed 600 sailors from the Ford-class design compared to the Nimitz class, not to save money, but because every human body is friction, consuming oxygen, generating heat, straining the sanitation system, requiring food and sleep and maintenance. The MQ-25 Stingray unmanned tanker robot was designed to buy sleep by removing pilots from the monotonous refueling orbits, preserving their neurological bandwidth for the 30 minutes of decision-making over the target. It helps. It does not solve the equation. By day 5 of Operation Epic Fury, the biological margin hit zero. Automation delayed the collapse. It did not repeal it. The Strait of Hormuz is open. The 17 missile launchers are scrap metal in the Makran Mountains. The Bavar 373 system is a debris field. Iran's integrated air defense network is offline. And somewhere on the Ford's flight deck, a pilot who has slept 4.5 functional hours in the last 24 hours is strapping back into an aircraft of $110 million for the next recovery. The mission did not end because Iran won. It ended because the ledger was full. Here is the question the Pentagon's Cost Assessment Office sits with every day of a sustained carrier operation. The SM-67 Interceptor costs $5.3 million per shot. It can intercept a ballistic missile. It cannot intercept a glucose crash. It cannot reset a sleep deficit. It cannot pay the interest on a deferred maintenance interval. The Ford is the most powerful machine ever built. It is also a closed